All right, when we talk about line best fit, it's talking about like if you have a scatter plot, okay, and we want to know what kind of line, whether it be linear, quadratic, exponential, those kind of things, will this scatter plot make. Okay, and this will make sense here in a second. So what I need you guys to do is open up Google Sheets and type in this information that's on this page that you were given. Okay. Information should look something like this. I just kept this one nice and short and sweet so that we can see the difference between the two. Okay. So what you're going to do is you're going to click and highlight over all of this information right here. And again, this will be on the test tomorrow, so this will take some practice. You're going to click and highlight over all the information, and you're going to hit Insert. And you're going to come down here and pick Chart. It pulls up a graph for you. Yep, Insert, Chart. Okay? You're going to get the one that says it's like Chart Editor. Okay, yours might look a little different depending on like what, like how updated your Google Docs is. Okay, I'm gonna come down here and under Setup, I'm gonna make sure that it's selected Scatter Chart for chart type. If it's not, sometimes it automatically picks the line chart. Come down and scroll down to where you see Scatter Chart down here. After you do that, you're going to come up here to Customize. You're going to find Customize. And you're going to come to Series. And you're going to scroll down to where you see Trend Line. Okay? So that's going to make a line. Oh, select it. And it's going to make a line that is best fit for this graph. So like, it takes our points and tries to find some line. So as you can see, like as your meal cost increases, your tip money increases, right? Okay. This is a linear example because it's a line, okay? One of your questions on your review is write the linear model that best represents this. To do so, you're going to come over here, and where it says label, you're going to bring this down and say use equation. And you're going to also click this show R squared. Okay, that's our R score. Okay. The use equation, that is this up here. Okay. Which is, oh gosh, where'd that go? What's happening? Series. There we go. So our equation, so answer question number 1, our equation is 0.0157 times x plus negative 0.299. That is the equation for this line, which is a ridiculous equation, and I wouldn't make you come up with that on your own. Oh, 0.157. Yep, you're right. Yeah.
So to find the equation, you have to use the use equation label and the show.
Yep. So this part right here is my equation. This R score is how well of a line does that fit my data. We want to get our R squared score as close to 1 as possible. So in this example, R squared is 0.982. That's really close and a really good example. Okay, that's a pretty good line for our data. Okay, so question number 1, you're going to put the equation. Gianna, you got a question? You can write y equals. Yeah. That's the variable x. Yeah, that means multiply. Yep. So the next question over here is, how good is the fit for the equation above? That is where our R score comes in. Okay? 0.982, I think it was, is a really good R score. That's really close to 1. We also can have an R score for a quadratic, which I'm going to show you here. Okay, so back at our information, I can come here and where it says type, linear means line. Okay, I'm going to drop that down and do polynomial. So now that's going to make it a polynomial to the degree of 2, which is a quadratic. That's going to give me a new best fit line, the quadratic line that fits that data. And we can see that my R score here is 0.994. That's even closer to 1. Okay? That's even closer to 1, meaning that actually this quadratic line is a better best fit line than our linear line. Okay, so when it says like, is this a good fit line? You can say yes, 0.982 is a good R score, but actually our quadratic line with an R score of 0.994 is closer to 1, meaning it's a better fit line. Okay? Good on that? Okay, yeah, Tiana? Quadratic. Yep. Okay, and then the last question on this one is, based on your mathematics, how much should a waiter expect to receive if the meal cost is $10.50? All you have to do for this question is plug in that $10.50 into that equation that you got for linear. So you would do our equation, which you saw on this. Let's make this back to linear. Okay. 0.157 times our x, which our x value in this case is $10.50. That's how much our meal costs. And then minus 0.299. And when you do that math, you should get the answer. A waiter will expect $1.35 for a tip. Okay. This last one I want to talk about before I send you off on your review is how to make an equation for these lines and then translate them. Okay. So what I'm going to do is write the linear function that goes through A and B. I have 2 points. How can I make a line out of those? Tiana? Yeah. Yep, you're on the right track. So the first thing you gotta do is find your slope. Okay? So in this case, my m is equal to my y2, which is 6 minus 1 over my x2 minus my x1, which is 3 minus 2. So in this case, my slope is 5. Okay? I need to write an equation for this. So now I have a slope and I have a point, so I'm going to plug it into point slope. Okay, so I'm going to go y minus my y1, which I'll do 6, is equal to my slope times x minus my x value, which is 3. And now it's just getting y by itself, so I'm going to do distributive property. Boom, boom. I have y minus 6 is equal to 5x minus 15. Add 6 to both sides. I get y is equal to 5x minus 9. Cool. Okay. So now I just need to plot that over here. What I did is I just made this I just wrote linear over this one, so I knew it was my A. Okay, or I can just write graph A. It's fine. I don't really care what you do on this one. And now you have to graph this point. So I'm going to find -9 over here, somewhere down here. And for every 1 I go over, I have to go up 5. So 1 up here. Let's just say 5 is 4. 1, 2, 3, 4. Boom. Every 5 I go up 1. Like so. That is my line. Okay? So tomorrow you're going to be given 2 points and you can make a line out of it. Good to go on that one? Okay. Write an equation with my absolute value. Okay? This one is super easy. Okay? We know that our line for absolute value is given by the equation y equals sum a, whatever we multiply on the outside, times my absolute value, x minus my h, absolute value, plus k. Okay? Where h and k are my vertex. So now I just need to plug in what I know. So here it says B is my vertex. So I'm going to plug in B. So I get y equals A times the absolute value of x minus my k, or minus my h, which in this case is 2. So I have minus 2 plus our k, which is, I don't know if this is recording still. There we go. Which is 1. Okay? Now I need my A value to figure out how to graph this. How do I find my A value here? It is slope, yes. But what I'm going to do is I'm going to plug in my X and Y value and then solve for A. So what you're going to do is you're going to plug in your Y value, which is your A coordinate. So 6 equals A times the absolute value of my x, 3 minus 2 plus 1. And now you just solve for A. All right, so we got A is equal to 5, so we have the equation y is equal to 5 times the absolute value of x minus 2 plus 1. So all I did is plug my A back in. And now I need to graph that. This is a translation, right? So when I have something in the inside, what happens? Inside of my absolute value. Yeah, it moves to the left or the right. Because this is negative, where is this going to move? To the right, positive. So we're going to go x plus 2. This one's my absolute value over here. I'm going to go x plus 2, so I'm going to move over here. And then I have that plus 1 on the outside. So where does that plus 1 move this point now? Up 1. So my vertex of this is right there. Okay? What does this 5 on the outside do to my equation? It's your slope. Is my absolute value going up or down? Up, and why is it up, Colton? It's positive. We're going to go over 1, up 5. Over 1, up 5. And that is our graph. So when this is a big number, it's not a fraction on the outside, it makes it super narrow. If it were to be a fraction, it would be super wide. Okay? Do you guys remember that from last week?